Today we're going to learn about the vertical asymptotes of rational functions. So first let's define a rational function. A rational function can be written as p of x over q of x, where both p and q are polynomial functions and q of x cannot be equal to 0. So a rational function would be a polynomial function over another polynomial where the denominator is not equal to 0. So here we have a function f of x. It's a polynomial function. We've got a polynomial over a polynomial. And f of x has a domain of all real numbers except for 2. So that means that this function exists for all x values except when x is equal to 2. And now if we look over at the graph, we've got these two kind of branches here, right? Here's one part of the function, here's another part of the function. But this line down here is not actually part of the function. This is a vertical asymptote. And what makes it a vertical asymptote is that if you follow along the function, as x is getting closer and closer to the asymptote, our function is getting closer and closer and closer to negative infinity. Same thing from the other direction. Here, f of x is getting closer and closer to positive infinity. So since our function is going towards the infinities, as x gets closer and closer to 2, our vertical asymptote is x equals 2. Here we have another rational function, g of x. G of x is rational because it consists of a polynomial over a polynomial. And the domain of this function we can find by setting the denominator equal to 0. So we know that x cannot be equal to 1/2. So the domain of this function is all reals except for 1/2. And then if we look at the graph, we see that when x is equal to 1/2, that we have a vertical asymptote. As x approaches 1/2, f of x is approaching infinity. As x approaches 1/2 from this side, f of x is approaching negative infinity. So our vertical asymptote is x equals 1/2. Now notice how closely the domain is linked with where the vertical asymptote is going to be. We can find the equation of a vertical asymptote the same way that we would find the domain of a rational function. So here's a third function, h of x, which is again rational because we've got polynomial over a polynomial. And if we wanted to find the vertical asymptotes, all we need to do is set the denominator equal to 0. And we get two vertical asymptotes, one at positive 1 and one at negative 1. So let's see what this graph looks like. And here's our graph, and notice that at x equals 1 and at x equals negative 1, we have vertical asymptotes. Whereas x approaches negative 1, our function approaches negative infinity. As x approaches negative 1, our function approaches positive infinity. As x approaches 1, f of x also approaches positive infinity, and from the other direction here, our function approaches negative infinity. So we can have multiple vertical asymptotes. And we have arrived at our summary here. We know that the line x equals a is a vertical asymptote of a graph if the function approaches infinity or negative infinity as x is approaching a from either direction, that's from the left or from the right. And we can find the equations of our vertical asymptotes by setting the denominator equal to 0, just like we would if we were looking for the domain of that function.